Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of PC, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about preemptive multitasking, round robin scheduling. So, multi means more than one. Task means some work. So means more than one work will be done by the operating system. So among multiple processes, which process is scheduled first? That is decided by the scheduling algorithm, that is round robin method. Round robin method means it follows first come, first served method with time slice. Means, suppose I am considering three processes P1, P2, P3. Among these three, which process comes first, that is scheduled for execution first. But the time limit based on each process is executed with equal amount of time period. We will get one example. Preemptive means if any new process enter into the ready state, the currently executing task is temporarily suspended and compare the currently executing task with the new process. Okay, we will go through one example. Okay, here three processes P1, P2, P3 with execution time, estimate completion time 10 milliseconds, 5 milliseconds and 7 milliseconds. Enter the ready queue together, means at a time they enter. First P1 enter, next P2 enter, next P3 enter. First P1, next P2, next P3. Okay. A new process P4 with estimate time 2 milliseconds. Enter the ready queue after 2 millisecond execution. After 2 milliseconds. Means after starting execution 2 milliseconds it will enter the ready queue. So assume all the process contains only CPU operations and no IO operations. Here time slice is 2 milliseconds. Means each process is executed 2 milliseconds. Again that is continuous, repeated, round, in the round circuit. Okay. So now, at the time of 0, what are the processes available in the ready state? P1, P2, P3. Which process entered first into the ready queue? P1. Okay. So that is scheduled for first. P1. So P1 is scheduled first. So its execution time is 10 milliseconds. So here time slice is 2 milliseconds. So it is executed 2 milliseconds. Okay. So after 2 milliseconds again P1 enter into the ready state. Again, which process is entered into the ready state next? P2. P2. So at the time of second millisecond, P1 stops the current execution compared with P4. Among them, P1 first, so P1 is continued, but its time slot is 2 milliseconds. It is continued. Okay. 4 milliseconds. Again, P3 2 milliseconds. Again, P4 2 milliseconds. Next, again, it is a process repeated. So, what is the process P1 remaining execution time? Already 2 milliseconds completed. Remaining is 8 milliseconds execution. So, again, P1 is scheduled. Next, again P2 entered into the ready state again, since it is preempted by P2. P4 execution is all complete. Since the execution time is 2 milliseconds, already 2 milliseconds is over. So P4 enter into the completed state. Again we will check what are the processes available, among them which one is comes first. Again already P1 execution is 4 milliseconds completed. Remaining execution time 6 milliseconds. So that is scheduled. Next, P2 already 4 milliseconds execution is completed. Remaining execution time is 1 millisecond only. So, again, P3 is scheduled. After P3, again go for P1. So, already P1 how many times completed? 1, 2, 3. This 6 milliseconds execution is completed. Remaining execution time is 4 milliseconds. So that is scheduled. P2 also complete. So then P3 how many execution times completed? 1, 2, 3. 6 milliseconds execution completed. Remaining execution time is 1 millisecond only. So (22 milliseconds). Next, again check the P1. How much time execution time is completed for P1? 2 milliseconds. So all processes P3 also completed, P1 also completed. Okay. Like this, with equal time period based on the time slice. Each process is executed as per time slice in the first in, first order. After that, again checks the ready state. This process is repeated until completion of each process execution. Now calculate the waiting time. Waiting time for process P1. So P1 is waiting time. How much time it is waiting in the ready state? P1 is entered into the ready state at the time of 0 and schedule execution immediately. So 0 milliseconds. Again, at the time of second millisecond, P1 enter into the ready state again. And when it is scheduled, 8th millisecond. How much time it is waiting? 6 milliseconds is waiting here. Again, at the time of 10th millisecond, it is enter into the ready state. So, and again up to 14th millisecond, it is waiting in the ready state. So, here 4 milliseconds is waiting. Again, at the time of 16th millisecond, it is enter into the ready state and it is up to 19th millisecond, it is waiting in the ready state. How much time? 3 milliseconds is waiting in the ready state. Again, here 2 milliseconds. Totally, it is waiting 15 milliseconds waiting in the ready state for this requirement. Next, waiting time for process P2. P2 enter into the ready state at the time of 0 and it is scheduled for execution at the time of second millisecond. So it is waiting 2 milliseconds here. Means 0 to 0 to and it is scheduled at the time of second millisecond. Again at the time of 4th millisecond, it is entered into the ready state. So from that to it is waiting 10th millisecond. Means totally 6 milliseconds it is waiting here. Okay. Next. Again it is enter into the ready state at the time of 20 millisecond. It is waiting up to 16th millisecond. Okay. Totally 4 milliseconds. Totally 12 milliseconds it is waiting in the ready state. Next, waiting time for process P3. Process P3 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 4th millisecond. Means it is waiting 4 milliseconds in the ready state. So 4 milliseconds plus again at the time of 6th millisecond it is enter into the ready state up to 12th millisecond. Totally 6 milliseconds it is waiting in the ready state. Again at the time of 14th millisecond it is enter into the ready state and waiting up to 17th millisecond. So totally 3 milliseconds it is waiting. Again at the time of 19th millisecond it is entered into the ready state and it is waiting up to 21st millisecond. Means plus 2 milliseconds. Totally 15 milliseconds is waiting in the ready state. Next, waiting time for process P4. Process P4 enter into the ready state at the time of 2nd millisecond and it is scheduled for execution at the time of 6th millisecond. So totally it is waiting 4 milliseconds. Okay. So the waiting time is, so at the time of 8th millisecond its execution completed, so it is entered into the completed state. So totally 4 milliseconds. So the average waiting time for this requirement is, summing all these times, by individual waiting times. 11.5 milliseconds. So for this requirement, the average waiting time for each process is 11.5 milliseconds. Now we can calculate the turnaround time for each process. Turnaround time for P1. Turnaround time means the time taken by the process to complete its execution from entering into the ready state. So P1 is entered to ready state at the time of 0 and its execution is completed at the time of 24th millisecond. Totally 24 milliseconds. Next, turnaround time for process P2. P2 entered into the ready state at the time of 0. Its execution is completed at the time of 17th millisecond. So totally 17 milliseconds. Okay. Next, turnaround time for process P3. Process P3 enter into the ready state at the time of 0 and its execution is completed at the time of 22 millisecond. Total duration is 22 milliseconds. Next, turnaround time for process P4. P4 enter into the ready state at the time of 2nd millisecond, and its execution is completed at the time of 8th millisecond. Total duration is 6 milliseconds. So, average turnaround time for this requirement is sum of individuals equal to 17.25 milliseconds. So like this, by using round robin scheduling algorithm, we can calculate average waiting time and average turnaround time for each process for this requirement and check which one is best for this requirement. Means in the same manner, for this requirement we can check what is the average waiting time and what is the average turnaround time for each process. So average waiting time for each, and all the algorithms. So which algorithm takes less waiting time and less turnaround time, that is the best for this requirement. We can implement that scheduling algorithm. For this topic, we can refer the textbook is Introduction to Embedded Systems by Shibu KV, published by the Tata McGraw-Hill in 2009. That is second edition. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.